Hey everyone, this is Muhammad Nadeem and welcome to my YouTube channel. Today in this video we will take the in-depth intuition of the Ohm's law. As the Ohm law relates some parameters and first we will discuss that parameters, and then after that we will derive some mathematical expression for that parameters in order to handle the in order to know the pattern and the relation between that parameter. We draw that parameter in the form of graph. So the next step will be graphical representation, and after that we will take some practical example in order to know and in order to master the concept of the Ohm's law in from the all dimensions. So let's start the video. Now I am considering the copper metal, copper. So here this is the copper rod. So let's consider the copper rod. This is actually a copper rod, and inside the copper rod there will be millions and billions of the copper atoms. So let's consider one of them is this is actually a copper atom, and the atomic number of the copper is 29. It means that there will be 29 electrons present in the shell around the nucleus, and inside the nucleus there will be large number of protons. So proton have the positive charges, these electrons have negative charges. There will be electrostatic force present between them. As electrostatic force is a function of distance, therefore the attraction between this last shell electron and this positive charge will be less. So the hold on this last shell electron will be less. Therefore this last shell electron even escape the atom at room temperature. Therefore we call this last shell electron as a free electron. So here inside this copper rod, inside this copper rod, here is not a single copper atom, but here is millions and billions of the copper atom, and each copper atom contribute the free electron. So here will be the sea of free electrons present inside this copper rod. So that sea of free electrons will move random inside this copper rod. Now if I connect this copper rod with the battery here I'm going to connect this side of the copper rod with the positive terminal of the battery, and this side of the copper rod with the negative terminal of the battery. Now due to electromotive force, the potential difference will develop across this battery, and due to this potential difference an electric field will create at each and every point inside this copper rod. So here the electric field will create. So electric field will create inside this copper rod, and we know the formula of electric field intensity as the force per unit charge. So from this we can calculate the force, which is equal to the multiplication of electric field intensity and the charge. So here in this case we have the charge is the free electron. So due to this potential difference the electric field is developed, and from the electric field we derive the expression for the force. So due to this potential difference electric field is developed, and due to which the force F with magnitude of this will exert on each free electrons in a specific direction. So here at each and every free electron the force F will exert due to that potential difference, and due to which these free electrons will start motion from one side of in this case from the left side of the copper rod to the right side of the copper rod. And we call this motion or this displacement at time t, we call them as a drift velocity. Now if I consider the area inside this copper, so here we have this area inside the copper rod, and the amount of these electrons are free electron that passes through this area, the amount of these free electrons that pass through the area is called the current. So the amount of the charges that passes through that specific area at time t is called the electric current. So from this explanation, I can say that due to this potential, the current will develop inside this copper rod. So that current is directly proportional to this voltage. If the voltage provided to this copper rod is increased, the current to this copper rod will be more. Therefore, the relation between the voltage provided and the current through the copper is a direct relation. So the current I through the copper rod is directly related to the voltage V. So in order to replace this proportionality sign, we take the equal sign and the constant instead of that proportionality sign. So and the V come in its own place. So the Ohm law take this constant as 1 over R. Here R is the resistance, and V come in its own place. So it is equal to V by R. From this we can write as V is equal to IR, and this is the relation of the Ohm law. So this is V is equal to IR is the relation for the Ohm law. This resistance is actually the opposition to the flow of these charges inside this metal strips. So inside this metal strip, if the force apply on this free electron, it will start motion, and during their motion it may collide to the other electron or the other copper atom. So during their collision, some sort of energy will release, some sort of unwanted energy will release in the form of heat, and we call that unwanted energy in the form of heat as resistance. So resistance is actually that, and the resistance depend upon the nature. Resistance depend upon the nature of the material. The metal have the conductor have less resistance, and the insulator have more resistance, and semiconductor have the intermediate resistance. So resistance depend upon the nature, and it also depend upon the dimensions. If I increase the dimension of the conductor, then the resistance will be less. The opposition to the free of electrons to the sea of electrons will be less. Therefore, the dimension is also a key factor for the resistance. And similarly, the temperature is also a factor for the resistance. The resistance is actually the appearance of the unwanted energy in the form of heat. And if the temperature of this wire is increased, so some of the heat is contributed by the collision, and some are contributed by the external temperature, due to which the overall resistance of the copper will be increased. So this all was about the Ohm's law, and now I'm going to discuss the graphical representation. This portion, the graphical representation of the Ohm's law. So for that, I take this example from the Google. So here we have the it may not seem clear. So here it is 1, this is 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is the value of the voltage. This is the value of V, and this is the value of current. This is the value of the current I. Its unit is ampere. And if the voltage was 1, the current is also 1. They are directly related. If this is 2, this is 2, and in the same way, the value of the voltage is equal to the value of the current. So here this is 3, 4, 5, 6, 7, 8, 9, 10. In order to draw this in a graph, and we take the current in the y-axis of this graph, this is actually the current, and on the x-axis of the graph we take the independent parameter. Here the independent parameter is voltage, therefore we take that in the x-axis, And from the graph we can say that if the current is 1, then the voltage is also 1. So here we take this data point. If the current is 2, the voltage is also 2. So the second data point is here. If the current is 3, the voltage is also 3. And if this is 4, this voltage is also 4. And in the same way, if this is 5, this is also 5. And if I connect all these data points, then we will take a straight line. So here if I connect these points, we will take a straight line. So we will take this straight line. So therefore Ohm law give us the straight line. Mean a linear relation. So it represents the linear relation between the current I and the voltage V. And this is the graph for different material. The first line is for for the material which has 1 kilo ohm resistance. The second graph for the other material which have 2.2 kilo ohm resistance, and the third one is for 4.7 kilo ohm material resistance, and this is for the other material which has 10 kilo ohm resistance, and similarly this is for other material. And if we see here for a specific material, here I consider, let's consider this is the copper, this is the copper rod. Let's consider this is the copper rod, and the copper rod have 1 kilo ohm resistance. This resistance will be constant throughout the data points which are connected by these lines. It means that the resistance is constant. During the derivation of the expression for the Ohm law, we take resistance as constant. So that means that and these are data points which are connected by these this line, the resistance will be a constant for a specific material. From the previous discussion, we concluded if there is the direct relation between the current and the voltage, the material will call the ohmic material. And if the relation between the current and voltage is not a linear, if it is a non-linear, then we will call that as a non-ohmic material. So there must be a direct relation between the current and voltage for the ohmic material. Therefore the graph of the ohmic material must be a straight line. But if the graph between the current and voltage is not a straight line, then the Ohm law for that material will not hold. The analogy of the voltage, the current, and the resistance is taken as here. If we have some sort of potential to apply the force on this box, and due to which that box will move. So the potential inside and the energy that we have is analogy for the voltage, and the motion of this box is analogy for the current, and the resistance upper between these this box and this inclination is actually analogy for the resistance. And same case, this is considered to be a current which is passed through this small hole here, and and the other person applied force on them to pass through this small hole, and the increase or decrease of this path is analogy for the resistance. In this case, the amount of the water in the dam is the analogy for the voltage, and the water through a pipe here is analogy for the current, and the resistance and the opposition for this water through the pipe is analogy for the resistance. So this was some basic explanation for the Ohm law, and I think you got my points, and that's it guys. Thanks for watching.